All right, welcome to lesson 108, transformation. So this is going to be entirely new to you. I'm really excited to jump in here and show you different types of transformations and what that even means. But first, to start off, we're going to do mental math. So that's going to start on page 561. So make sure that you're there and that you're following along. Please feel free to pause the video anytime you need a break or you need to look at something more carefully or if you need more time working on this mental math. All right. So let's start with letter A. 70 times 70. What is 70 times 70? It's 4,900. Letter B, 296 minus 150. What is 296 minus 150? The answer to that is 146. Letter C, 25% of $20. What is 25% of $20? All right, that's going to be $5. Letter D, $8.23 plus $8.99. What is $8.23 plus $8.99? The answer there is $17.22. Letter E, 75 divided by 100. What is 75 divided by 100? And that would be 75 hundredths, or 0.75. Letter F, 800 divided by 40. What is 800 divided by 40? Answer there is 20. Letter G, which is greater, 2 liters or 3,000 milliliters? What's the greater amount of liquid here? That would be 3,000 milliliters. Because 2,000 milliliters would be 2 liters, and that's obviously less than 3,000. And then letter H. We have 8 times 8 minus 4 divided by 2 plus 5 divided by 5 times 8 minus 1 divided by 5 times 2 minus 1 divided by 3. And your answer there is 7. All right, answer there is 7. So what we're going to do today is we are going to look at transformations, like I said, so make sure you're paying good attention. And at the end here, I'll give you a lot of definitions. So what we're looking at here is 2 different figures. We have triangle ABC and triangle XYZ. And what we're going to do is try to figure out if these 2 figures are congruent. So if you're not familiar with the term, it's not writing very well there. Let's do it here. We're going to figure out if these 2 figures are congruent. And what congruent basically just means is that the figures are the same. The pen here is giving me a little trouble. Same size and shape. So they both need to be triangles, the exact same type of triangle, and they need to be the exact same lengths and angles within those triangles. So that's congruent, same size and shape. One way to figure out if 2 figures are congruent is to position them one on top of the other. So if I could pick these 2 triangles up off of my screen and lay them on top of each other and they perfectly lined up, I would know they are congruent. So I can't actually physically do that. I can't take them off this screen and move them around. So what we're going to do is we're going to use some transformations to sort of position them on top of each other on this screen still. So we're going to move those shapes around. Imagine they're just like stuck to the screen, but I can still move them around. Okay, so try to visualize that with me here. So first what we're going to do is we're going to position triangle ABC. We're going to put them in the same position, okay? The same position. So the first thing we need to do, so just look at this top figure here. The first thing we're going to do, so remember on this previous slide before I even get too far, triangle ABC is sort of lying on its side, and let's say triangle XYZ is upright. So the first thing we're going to do is we're going to rotate triangle ABC so that it is now upright. So B used to be here, A used to be here. My pen is really giving me troubles on this lesson. I'm so sorry. this is B, we took that triangle and we rotated it upward. We didn't really move it too far. We just rotated it upward. So now they're both upright, okay? So that's our rotation. So we rotated it 90 degrees. Okay, the next thing we're going to do to get these two figures sort of on top of one another is we're going to move it over. So here's triangle ABC, and we're just going to slide it over without really moving it. And that sort of sliding over is called a translation. Okay, so first we had a rotation, then we had a translation. So now we would say these two triangles are sort of back to back. Okay, so AC is aligned with this line AC. Remember, we talked about how you can name lines. AC is aligned with XZ. They're really just lined up with one another. The last thing we're going to do is we're going to sort of flip triangle ABC over so it's exactly congruent now and lined up with triangle XYZ. And so that sort of flipping over is called a reflection. So A and C, remember, we're already lined up with X and Z, and we really just flipped it so that B is now lined up with Y. So that's a reflection. Just think about an image in a mirror. It's just flipped. So we took that triangle and we flipped it over. Okay? So in 3 different kinds of moves that are called transformations, we made it so we could see that triangle ABC was congruent to triangle XYZ. So what I'd like you to do is take a moment and to write down these different types of transformations. And I'll write that up here. Transformations. So the first was a rotation. That's turning a figure about a certain point. So if you'll recall, we had the triangle like this. And so we sort of just like anchored it here. Let's say you put your finger on that point and then you rotated it up. So then it was right here. But that point didn't move at all. It was the other 2 points that moved. Translation is sliding the figure in one direction without turning it. So we had the triangle here, and all we did is we slid it over. So it was just in a different position, but it wasn't moved or turned at all. And the last one was reflection. So we're reflecting a figure as a mirror or flipping a figure over a certain line. So that line in this case was the AC line. We didn't move it. We just sort of kept that line the same, and we took this point and just flipped it over. We flipped it over so the triangle looked like this now. Okay? So those are the 3 types of transformations that you'll want to be familiar with, and you need to understand sort of how they are used. So we're going to identify whether something was rotated, translated, or reflected. So pause the video if you need more time to write those down or just to mull them over. And what we're going to do, because I'm not with you, actually, if you can do this on your own, this would be really lovely. The activity on page 562 shows you taking scissors, pencils, paper, and actually cutting out these triangles and moving them around to do those 3 different sorts of transformations. So, because we can't do that, what we're going to do is just look at the figures and imagine what transformation took place. So that would be on page 563. Ooh, laptop is getting very warm. All right, so take a few minutes on page 563 to look at the practice set. And man, I should have drawn out these triangles, but I'll do it as we go. So take a few moments to work on the practice set. Okay, welcome back. Hopefully you paused it, took a few moments, or maybe you were just totally confused and wanted to be walked through with this. So what this is basically showing you is 2 different triangles. Well, really, they're the same triangle. And the Roman numeral 1 is showing you the first position of the triangle. Roman numeral 2 is showing you the second position. So you need to determine what sort of transformation took place here. So if our first triangle was here, and then something happened, it was either rotated, translated, or reflected to become here, what transformation was that? We're going to say that this was reflection. Man, I'm really sorry that my pen is acting out. Reflection. So it was sort of reflected over this line. So this line didn't really move, but the point was reflected like in a mirror. For letter B, we've got 2 triangles. how did triangle 1 get over here? That was a translation. So you'll see that all of the points are in the same spot, but the triangle has literally just moved. It was slid over in a translation. Okay, triangle C. So we have our first triangle up here, and then our second triangle here. What happened? Okay, what happened? This was rotation. So remember that rotation is turning a figure about a certain point. So like I said for that first one, it's as if we held our finger to this point here and we just rotated the triangle. Ooh, I didn't know I could do that. That's really cool. We just rotated the triangle around that point. So this point turned here and this point turned here. Letter D, what happened here? So we've got our first triangle, then we have our second triangle. How did this happen? So let's think of what could happen. Remember when a triangle just moves laterally, that would have been a translation, but the points aren't in the same spot, so it looks like we have a second side of transformation. So it was translation and reflection. So it looks like this triangle looked in the mirror and now it's reflected over along this line. So it moved over, reflected on that line, and sort of brought that one point over. Letter E. So we've got our first triangle up here, or actually that's our second triangle. How did our triangle get over there? Well, one thing that had to happen that looks pretty apparent is rotation. So it looks like our triangle was fixed here and then rotated upward. But if you can visualize that, if we just rotated this whole triangle upward, it would actually look like this. So that's what happened after the rotation. How did we get it to look like this? It must have been reflection. Reflection. So the triangle was rotated up and then reflected about this line, so it changed that point. Okay, so those are all the transformations. And then letter F. Let's see, letter F. For exercise F, ABC is reflected across the y-axis. Write the coordinates of the vertices of triangle ABC and the coordinates of the vertices of its reflection, A prime, B prime, C prime. Explain all answers. Okay. So let's talk about this one. So first you had to look at the original triangle and then just find its coordinates. So A is at -2, 4, and that is a really small coordinate plane, so hopefully you guys could see that all right. B is -1, 1, and C is -4, 2. So I'll write those for the original ABC, -2, 4. I hope you guys saw the instructions in the front there. I should have pointed that out. B is -1, 1, and C is -4, 2. So it says it was reflected about the y-axis. So basically the y-axis, let's say this is our triangle, this is the y-axis. The y-axis was sort of our line upon which it was reflected, and this whole figure was reflected to the other side. Okay? So it was like that whole triangle was looking in the mirror, and this was the point of the mirror. So now we have to find this new triangle, which those little dashes you see superscript by this letter means you would read it as prime. So A prime, C prime, and B prime. Okay, so we have to find those coordinates now. And the funny thing about these coordinates is you'll see this relation here in a second. So A prime is 2, 4, so it's +2, +4. B prime is 1, 1, and C prime is 4, 2. So really their position height-wise didn't change. That just goes to show you I didn't draw that reflected triangle very well. So their height didn't change. Their y-axis value didn't change, but their x-axis value did change, okay? Because they were rotated about the y-axis, that sort of stayed the same, and all of the x positions changed. And you'll notice that they became the opposites, okay? So I hope you enjoyed this lesson. I really like it. I like that it's new and different, and it really kind of involves some more logical thinking, some more mental thinking here instead of just some obvious answers. So I hope you guys liked that lesson. You'll find your homework in the description box on GradeLink and on Google Classroom. And like always, let me know if you guys have any questions.